form carbon dioxide and water. So student must have in their minds that the complete combustion of hydrocarbon, whether it is the alkane or alkene, will always give us the carbon dioxide and water. If it is alcohol, alcohol can also give us the carbon dioxide and water on the complete combustion. Now your task is to balance these chemical equation. So whenever you have a task to balance the combustion equations, always balance in this sequence. First of all, balance the carbon, then hydrogen, and then oxygen. Now look at the number of carbon atom. There is just one carbon. So on the right hand side, one carbon already balanced. Hydrogen 4. So if you put 2 here, you will get 4 hydrogen. Now count the oxygen atom on the right hand side. There are 4 oxygen atom, 2 on the left hand side. So if you put 2 here, you will get a balanced equation. Now the second equation, there are 2 carbons. So put 2 before carbon dioxide, 6 hydrogen. So put 3 here. Then 4 oxygen are here, 3 here, so 7 oxygen. So if you want to make it 7, you can say 3.5. So if you multiply the 3.5 with 2, you will get 7 oxygen. Now, how many carbon? 3 carbon. Okay, 3 carbon, 8 hydrogen. So you can put 4 here, 6 plus 4, 10. So you can put 5 here. Now, 4 carbon, you can put 4 before carbon dioxide, 10 hydrogen, you can put 5 here, 8 plus 5, 13. So if you want to balance this, you can write 6.5. Then 5 carbon, so you can put 5 here, hydrogen 12, you can put 6 here, 10 plus 8, 16. So you can put 8 here. So these are the balanced chemical equation. I have balanced by taking the 1 mole of every alkane. So if you want to get the balanced equation by using the 1 mole of alkane, you will get this type of balancing. Just look at the number of oxygen atom. There is a symmetry. I mean, now there are 2 high oxygen atoms. So if you add 1.5, you will get 3.5. 3.5 plus 1.5, 5, then add 1.5, 6.5, and then 1.5, 8. So if you have a sequence of the alkanes, oxygen, the number of moles of oxygen are adding in 1.5. So if you add 1.5 moles of oxygen, you will get the next. Look at the number of carbon atoms. Now 1, 2, 3, 4, 5. So if you have the carbon number here, if you have a carbon number 1, you will get 1 here. The 2, then you will get 2 here. 3, then you will get 3 here. 4, and then before carbon dioxide, you have to put the coefficient 4. So if you have a 5, then 5 here. Now look at the hydrogen atom. There are 4 hydrogen atoms. So if you divide by 2, you will get a number like this. Okay, so look at the hydrogen atom. If you want to make the hydrogen balance on the right hand side, take a half of this number. 6 half means 3. So we can put 3 here. 4 half, 4. Okay, 10 half is 5. So you can put 5. 12 half is 6. You can put 6 here. So if you have fixed the numbers on the right hand side, then you can balance the oxygen. But this equation that can also be balanced like this, that if you want to make as a whole number, then you can multiply this equation with 2. So here you will get a 2, here you will get a 7, then 4, then 6. So these 2 equations, they are considered as a balanced equation. Either you put the coefficients 1, 3.5, 2, 3, or you put 2, 7, 4, 6. So these are the balanced chemical equations. So from the combustion equations, you may get idea about the formula of the organic compound, or specifically alkanes or alkenes. For example, if you have any unknown alkane, and if it reacts with the oxygen, and you are getting carbon dioxide and water. Now, if you have fixed the number of coefficients, mean 4 is here. If you have 4 is here and 5 numbers here. So you can predict the formula of this unknown alkane by using the coefficients which are before the carbon dioxide and by before the water. Now you have four. I have already told you that the number of the carbon atoms, if you have 4 before the carbon dioxide, it means that there are 4 carbon atoms in the hydrocarbon. So the value of X must be 4. Now look at the number or the coefficient which is before the water. Now, if you have a 5, make it double. So to get the value of y, because there is a number 5 is there, so if you make it 2 times, you will get 10. So this was actually butane. X is 4 and Y is 10. So the formula of this hydrocarbon or alkane, it must be C4H10. Then you can balance the rest of the, if you want to get the balanced equation, you can balance the rest of the element. And there is just one element left, which is oxygen. It means that from these coefficients, you can get the formula. But generally, alkanes, they have the general formula of the balancing as well, that if you have a general alkane, so you can balance these alkanes like this formula. So if you have X number of carbon atom, then put X here. Y number of hydrogen atom, just take the Y by 2 here. And then to get the oxygen, X plus Y by 4. So this is the general formula. You can also predict the number of carbon, hydrogen, and oxygen. Okay, so just try this general formula to get the idea. Now, there is another thing, that if you have the volumes of the gases, I mean, if you have a hydrocarbon and if it is burned in the oxygen to get carbon dioxide and water. Now, let's say we have 10 centimeter cube of hydrocarbon and 50 centimeter cube of oxygen, which was in excess. So by reacting 10 centimeter cube of hydrocarbon and 50 centimeter cube of oxygen in excess, the by taking this much amount of hydrocarbon and 50 centimeter cube excess of oxygen, we will get 40 centimeter cube of gas at room temperature. Now, this is in excess. It means the hydrocarbon is a limiting reagent. This is limiting reagent. Limiting reagent is the reagent which is used completely. So 10 centimeter cube of hydrocarbons, they are used completely, but oxygen is in excess. So not all amount of the oxygen will be used. Some oxygen may left at the end of the chemical reaction. So 40 centimeter cube gas at room temperature. We will get the 40 centimeter cube of gas at room temperature by mixing 10 centimeter cube of hydrocarbon and 50 centimeter cube of excess oxygen. When we say room temperature, just look at the state symbols. This is a gas, this is a gas, and this is a liquid at room temperature. So if you have a 40 centimeter cube of gas at room temperature, because the hydrocarbon is completely used, so in this 40 centimeter cube, no contribution of this hydrocarbon, and water is also not present because at room temperature, this is not a gas, this is a liquid. So this 40 centimeter cube contains only oxygen and carbon dioxide. Now, if I pass the 40 centimeter cube of this gaseous mixture, which contains oxygen and carbon dioxide, from the potassium hydroxide. Now, potassium hydroxide is a base, carbon dioxide is a acidic gas, oxygen is a neutral gas. And if I say that the 30 centimeter cube of the gas is still there. Now, this 30 centimeter cube of gas is oxygen. Why oxygen? Because hydrocarbon was the limiting reagent. So no hydrocarbon will be left over in this gaseous mixture. Oxygen, excess, not all the amount of oxygen will be used. Carbon dioxide, gas. So in this gaseous mixture, carbon dioxide may be present, and at room temperature, the water is a liquid. Water is not a gas, so you can skip the water. If you skip the limiting reagent and the water, it means in 40 centimeter cube, only carbon dioxide and oxygen are there. And if we pass through the potassium hydroxide, carbon dioxide being an acidic gas that reacts with the potassium hydroxide, and you will get only oxygen. So if we want to find out the volume of oxygen used at the start of the experiment, you took 50, 30 is left, so 20 is used. Whereas the volume of hydrocarbon used, that is given because this is the limiting reagent, so 10 centimeter cube is used up. Now the volume of carbon dioxide produced. Now the gaseous mixture contains 40 centimeter cube of oxygen and carbon dioxide. 30 centimeter cube oxygen is left. So if you subtract this amount, you will get 10 centimeter cube of carbon dioxide produced. Now, if we take these volumes of reactants in the product, we will be able to predict the formula of the unknown hydrocarbon. So we have 10, 10, 20, and then 10. So simplify, you will get 2 here. You will get 1 here, and you will get 1 here. So if you want to get the formula of the hydrocarbon, just balance the oxygen. There are 4 oxygen atoms. So 1 is there. It means you can't put any number here. So 2 oxygens are there. So to balance the oxygen, definitely you will have to put 2 here. Now there are 4 oxygen atoms, but look at the number of carbon and hydrogen. There is just 1 carbon because 1 coefficient is there and 4 hydrogen. So 1 carbon, 4 hydrogen. It means this was the data of methane. So by doing the combustion analysis, you can predict the formula of unknown alkane. This is the way. Alkanes in incomplete combustion, they will always form carbon monoxide and water. So this is methane. In the limited supply of oxygen, you will get carbon monoxide and water. So if you want to balance this chemical equation, look at the number of carbon, hydrogen, and oxygen. There is 1 carbon, 1 carbon. There are 4 hydrogen atom. Okay, so if we put 2 here, you will get, okay, if we put 2 here, you will get 4 hydrogen atom. Now look at the number of oxygen atom. Number of oxygen atom are 2 plus 1, 3. So you can, to make it 3, you can write like 3 by 2. So if you cancel 2 with 2, you will get 3. But to get a whole number, you can multiply this equation with 2. So this will be the balanced chemical equation. Carbon monoxide is a poisonous gas. and when it is inhaled, causes suffocation.